Good morning, everyone. Please, as you come in, open up your dimensional analysis handout from Wednesday's class. Please open up your dimensional analysis homework from from Wednesday's class. A couple of quick announcements. In Canvas. This assignment is actually set to be due on Tuesday. This assignment is set to be due on Tuesday. It says mole homework. So if you would please open up your dimensional analysis handout. Also open up your periodic table. Open up your periodic table and take out a sheet of paper or prepare to take notes on a piece of paper for today. How's everyone doing? Show us by way of reaction. How are you doing today? How's everyone doing?
Can I ask a question before we officially start the lesson, Dr. BJ?
Yes, please.
So there's a mole conversion homework that's due today. And did you just say that's going to be due on Tuesday?
Yes, we're going to move it to Tuesday.
Okay, thank you.
Yeah. All right. Any other questions? How are you today, Ms. Ball?
Very good, thank you. Very good, yes.
Excellent. All right. So if you see, you're not seeing my picture today, my face today, because I have a sheet of paper here that I'm going to use to sort of practice some of the ideas that we presented in last class's dimensional analysis. So please open up your mole homework, that handout that we started, and also take out a piece of paper, writing utensil, get prepared. We're going to review dimensional analysis. Then also open up your periodic table. Open up your periodic table online, on your phone, or some other device. All right, so here we go. Ready? The mole. The mole is a unit. The mole is a unit like any other unit. We talked about a meter, for example, and why, for example, we use standard units to think about measurement. Why we use standard units as measurement. And so here, making a copy based on what we did on last class, I want to make sure we just practice and understand what's going on. We understand that units of measurement are designed to allow us to all understand what's going on at the same time. And so in this first relationship where we see 1 gallon is equal to 4 quarts, 1 gallon is equal to 4 quarts, we can begin to sort of understand that, well, yeah, if you're in the United States where we use imperial units, the gallon makes perfect sense. And well, sometimes you don't need that much. So you need a smaller unit that's equivalent. What is the equivalent? For example, we talked about a dozen. A dozen is 12 objects, and we get it, no problem. Where we started to sort of deviate from understanding the basic common units is when we did our mole challenge, and we began to talk about decades and centuries as standard units that are based on the metric system. Dec, 10, cent, 100. Yeah, that's standard versus what we understand on these other very fancy units like a gross. We learned that a gross is 144 objects, but if you have a good, strong math sense that you realize 144, that's 12 times 12. So a gross is equivalent to 12 dozen. Whoa, a ream. 500 sheets, because when we think about sheets of paper, We don't buy paper one sheet at a time. We buy it a huge stack at a time. And well, if we said, okay, I'm going to buy a stack of paper, and we go to Staples to buy a stack, and it's a certain number, but then we go to Office Depot and say, can I have a stack of paper? Well, unless we have a standard saying what a stack is, they might sell us something less than that. So at the end of the day, these questions here, how do we know? We know by Googling it now, but when we Google something, what we're basically saying is we have come to a consensus. We agree. Well, how big are atoms and molecules? They're actual numbers. And so I want to make sure everyone understands that. So here, if we're asking how big is an atom, we need to decide what type of atom we're talking about. So atomic radius, and everyone please write this in your notes on that document. Atomic radius, what does that mean? Atomic radius. Atomic radius, by definition, tells us the distance of an atom's nucleus to its outside. What are we talking about, Dr. DJ? See, look, let's scroll down and look at these pictures. The atomic radius is a measure from the nucleus to the outside of an element. Here, they're showing you molecules. So atomic radius in general, when we have, and here's a slide, right? Here's a slide. When we start thinking about the size of an element, one way we can look at it is to think about its radius, how it behaves when it's bonded. But here, this is the one I want everyone to see. When we think about atomic radius, that's a way for us to think about its size. So everyone, depending on what you're looking at, we can think about, and I'm going to click it here so that you can see it large. When we talk about the size of an atom, we're typically talking about something called radius. Now you can click whatever you'd like. You can click whatever option you would like, and you can do like we did before. Click on the image, copy the image, and I'm going to actually now paste it into my document here. So I'm going to paste how big are atoms. I want everyone to sort of understand when we are talking about atoms, it is a thing that people actually measure, and it changes, and it's different than molecules. The other thing that I want to point out, though, is that, well, it's related to the periodic table. That is a huge, big idea. So everyone now, please Google atomic size and snatch a picture to place in your notes. Everyone, Google atomic size and snatch a picture. When you have pasted an image of atomic size that represents and makes sense to you, let us know by a thumbs up. All right. So these other questions, can you see, touch, or manipulate a single atom or molecule? What does your gut tell you? Can you see, touch, or manipulate a single atom?
No.
Absolutely not. And that was the big idea. They are so small, we can't see a single one. And so scroll down here a little bit. When we get to that big idea, when we really understand that, we begin to understand that there's really no way for us to make sense of a single atom except to use a different unit. And the unit that we use is called the Dalton, because the more sensible way to make sense of atoms is by mass, by finding their mass. And so we left class the other day. I think this is where we left off. Is this where we left off, Miss Syed? Yeah. We left off the other day looking at the difference between single atoms like nitrogen and molecules like nitrogen. This is still nitrogen, but it's a nitrogen molecule. That's a big idea. All right, so unmute yourselves. Did anyone finish up these two elements, ZR and TH?
I did.
All right, what's ZR?
91.22.
91.22 units, which
Daltons.
yeah, which is Daltons. Good, good. And because it's Daltons, what that means is that 1 mole of zirconium equals 91.22 grams. All right, let's hear from one other person. What's TH? What element?
Thorium. and
Thorium.
it's
Good.
232.038 Daltons.
Yes, which means that one mole of thorium equals 232.038 grams. Yes, beautiful, beautiful. All right, so now here's my question. When we look at this, we can use it to solve problems. And so everyone, now I want to spotlight my video so that you see this. Hold on. I'm gonna spotlight my video so that everyone can see here. So read the question to me, please, Ms. Syed.
Yes. Sorry,
Here's the question. You have 12 grams and it's asking you how many moles that is. Well, before we answer that question, we need to look at the periodic table. When we look at carbon, atomic number is 6, 12.01 is our units. What does that mean? That means that 1 mole of carbon equals 12.01 grams. Are we together on that? Hopefully you're saying yes. And so dimensional analysis says, all right, what are my conversion factors? Unmute yourself or call on someone, please.
Sophia, do you want to try that? What are our conversion factors over here?
I'm not so sure, but if there's a way that I can know, could you let me know?
So
Yeah, let's make a fraction. Once we have a definition that's equivalence, just gonna say I either have 1 mole over 12.01 grams, or what's the reciprocal of that?
You mean like the flip of it?
Yes.
Oh, that's 12. It would be 12.01 grams over 1 mole.
Exactly. Everyone, this is what that means. This is what that means. And so now we use the conversion factor to solve and change the unit. So my original question starts with 12 grams. All right. So to solve this, the solution, I'm going to always start with what I'm given, 12 grams of carbon. That's where I start. Then I'm going to make a bracket because I'm going to use one of my fractions. The fraction that I need to use will have grams in the bottom and moles in the top. So which conversion factor do I need to use? The one on the left or the one on the right?
Left.
The one on the left. So I'm going to use this one. So I'm going to circle it and get rid of that one. So now I'm going to have 12.01 grams here, 1 mole there. Then I cancel my grams and I'm left with my desired unit. Anything expressed in the denominator is divided. So what is 12 divided by 12?
1.
So I have 1 mole of carbon. Done. It's as simple as that. So let's move on to question number 2. Please read the question, Ms. Syed.
Yes, I'm on it. It is 46 grams of sodium is equal to how many moles?
All right, let's look at the periodic table. Let's look at the periodic table. What is the atomic mass of sodium?
Twenty-two point 9897693.
So let's round that to 23. Are we good? So I have 23 as my molar mass, my atomic mass of sodium. So what does that mean then? That means that 1 mole of sodium equals 23 grams. That's my equivalence. Manuel, what are my conversion factors then?
So your conversion factors would be 1 mole over 23 grams, or it would be 23 grams over 1 mole.
Beautiful. All right, Tanner, I'm ready to do my solution. What am I starting with?
I don't know.
What's the question?
Sorry, I was making food.
All right, what is the question?
I don't know.
It's on the screen. Can you see the screen?
Yeah, 46 grams Na. Wait, what's Na again?
Sodium.
Sodium equals.
All right, that's it. So we start with what we are given. The next step, David, what's the next step in solving this? Look at your notes from before. Jake, help him out.
Oh, sorry. What were you asking?
What's the next step in doing this solution?
I'm sorry. I don't know.
Does anyone know?
Can I guess?
Yes. Who was that speaking? I don't know.
I was just asking, can I guess?
Yes.
Figure out which conversion factor.
Yes, good. You have to figure out which conversion factor you need by adding the brackets. And so grams is here in the numerator. So where does grams need to go?
Denominator.
Very good. So which conversion factor do I need?
The left.
The one on the left. I need this one. Don't need that one. So 23 grams is 1 mole. What's 46 divided by 23?
2.
All right, beautiful. All right, now let's do one that's not on your sheet. Let's do one that's not on your sheet. What if I said I have 0.45 moles of hydrogen. 0.45 moles of hydrogen. What is the first thing I need to do?
Figure out the atomic mass of hydrogen.
Yes, which is
1.
1, but I have a molecule here. So
Oh, it would be 2.
very good. So my molar mass is 2 Daltons. What does that mean? What does that mean? Wesley?
Does that go into one of the conversion factors?
Yep. So 2 Daltons means that 1 mole of hydrogen equals what?
2 Dalton. All right.
What is a Dalton? Look at your notes from before.
Unit.
2 units. And in terms of a mole, what's the unit that would go there? Somebody help me out.
Hydrogen. Hydrogen.
1 mole of hydrogen is equal what quantity?
2
Basil?
grams.
2 grams.
Oh,
All right. Charlie, what are the conversion factors?
Could be 1 mole over 2 grams,
Or?
or 2 grams over 1 mole.
Good. All right. Wesley, how do I
Yes.
solve it?
You have to take what they gave you. So
That's 0.45 moles of hydrogen.
and then you use 1 mole over 2 grams.
Do I? What's in the, I'm giving moles this time. So what unit needs to be in the
This-
denominator?
Is the mole that
The
they
mole.
give you for the denominator?
Right, so this time we need to use this one because the
Oh, okay.
units have to cancel. So the 2 is going to be here and the
Mhm.
1 is going to be here. All right, who's got the final answer? How many grams?
0.9.
Very good. So I have 0.9 grams of hydrogen. Yes. Yes. All right. So the idea here that I want to make sure that everyone understands is that when we look at these problems on this sheet, when you see the problems on the sheet, understand that's all that you're doing. You're flipping the molar mass units in the conversion. You can do the same exact thing with the other units. The process is an old process that we have done and been doing, but because we are learning this way, it has been difficult for us to reinforce and make sure that you understand. However, for the very basic relationships, we expect you to be able to do that. Everyone on your own, please go ahead and do the last one in that first box. It's 315,000 moles of water. It's 315,000 moles of water. What do we do with that? 315,000 moles of water. Somebody walk us through. What is the molar mass of water? One mole of water equals what?
Is it 18?
Yes, nice. It's 18 grams. How did you get it? Talk to us.
I added the 2 hydrogen molecules to the 1 oxygen,
Yes, you have
which added together 18.
2 hydrogens plus 1 oxygen. The atomic mass of hydrogen is 1. The atomic mass of oxygen is 16, so it's 2 plus 16 to give us 18. Yes, beautiful. And so now, if we start with 315,000 moles of water, somebody walk me through it. Let's hear from someone else. Please call someone, Miss Syed.
Jake, did you want to try that one?
I kind of don't really know how to do it, but
Okay, let's see. Our given over here is 315,000 moles of water, right? So which conversion factor do we use? Okay, let's start with the conversion factor. What is our conversion factor? 1 mole of water is equal to
18 grams.
18 grams of water, yes. So now how can we, if you write it out in your notes, write it out. 1 mole over 18 grams of water is equal to, if you flip it again, 18 grams divided by 1 mole of water.
Yeah.
What do we call these two fractions? Somebody?
Are they called conversion factors?
Yes, very good. So these are our conversion factors. Conversion factors. And so the question here, the question is a conversion. They're saying, okay, if you have 315,000, you have 315,000 moles of water, they want to know how many grams. So that's the question. So now that's the question. And so here we go. Once we have that, we can write it out again. So I'm going to do this 315,000 moles. What is the next step? Anybody, everybody, look at your notes that we just completed. It's still on the screen.
Into 18 grams divided by 1 mole.
Very good. You choose the conversion factor that has the starting unit in the denominator so that it cancels. 1 mole here. And then 18 grams here. Once you have that, we can see how to cancel these units. And then my solution just becomes 315,000. Use your phone or a browser. 315,000 multiplied by 18 grams. What is your final response, please?
$5,770,000.
Very good. Call out just the digits. 5,
670
670
000.
000 grams. Excellent. So that's how you'll do these. All right. That is how you will do these. And again, like I said, it will be due on Tuesday. But I wanted to take just another minute or so to finish up our class discussion, and then we're going to allow you to work in breakout rooms or work rooms for the remainder of our time together. So this is the conversation about the mole. But before we go into breakout rooms, our workout rooms for the remainder of the class, I wanted to go back to the periodic table and look at this idea. I'm going to put a link in the chat for everyone. Please copy the document that I have, please copy. What you will see is a student spreadsheet that looks like this. Once you have it, please show by way of reaction. Please show by way of reaction. Okay, good. And so what I want to make sure everyone is able to do, is, again, practice graphing, right? Here's this practice thing that I want to make sure everyone will do, and that's what you're asked to do. We're getting ready to start talking about the periodic table a little bit more. And what I want to make sure you know how to do is how to use the periodic table to create a spreadsheet, but also what that actually means. And so we're going to take about 3 minutes, and I want everyone to follow along with me because we will be looking at this in your final folder for the quarter. I want you to graph the first column of data and the third column of data for atomic radius. We just talked about atomic radius, and so I'm going to show you how to select just those two columns. So if you click the A, it will highlight the A. Hit the Control key on your keyboard, drag over to C. Excuse me, not Control. Hit the Command button on your keyboard. Sorry, I'll do that again. So you click the A and it highlights A. Hit Command and C, and it will highlight just those two sets of data. Then we're going to insert a chart. So insert chart, and it is going to create a graph that allows you to see the patterns of atomic radius and atomic number. Once you see it, click the 3 vertical dots and move it to its own sheet. And there you have it. Bing, bang, boom. By show of reaction, how many of you were able to create? How many of you were able to create atomic radius? Excellent. Now I'd like you to repeat that for column D, E, and F. Everyone repeat that for D, E, and F.
I sent you a message.
No, we don't. It's an hour today.
It is?
Yes, it is, because we had 45 minutes on Monday.
Okay, thank you.
I know these schedules are terrible.
I got so scared.
I will show you one more. So you click the A. Now I'm going to select D. So I have 2 columns selected. Insert chart.
Wait, should we do that? Select A and D.
Yes.
Okay.
I want you to do A and D, A and E, A and F. I want you to do all of the remaining columns. Once you have completed those columns, at least one other one, give us a thumbs up, please. Excellent. And so we're getting ready to open up breakout rooms according to the poll from earlier this week. Earlier this week, we asked you in the poll what kind of workroom you wanted to be in, you were okay with being in. Whether you wanted teacher help, whether you wanted to be in an open group meeting with your peers with your camera on and your mic on, whether you wanted to be in a quiet room, whether that's in a group or you wanted to work independently. We're going to open up breakout rooms. If you wanted to work in a quiet room, work independently, you are free to leave now. However, I want to be clear. I want to be clear. The task is to fill in column B. So you need to use your periodic table website to fill in column B and graph all of the remaining charts. Then we want you to, in your notes, define the properties that are there. In terms of understanding all of this task and how it fits, I want to make sure that everyone is clear and understands that in the module, we have added the information. Did you add the slides, Ms. Syed? I don't see them here.
No,
But
I didn't.
I have added periodic trends. So here is the data if you need it. So all of this is there. This is the task that you have. Are there any questions?
Sorry, I was just, so did you mean if we want to work in quiet groups, we're free to leave the meeting?
Yeah, yes, but
Okay.
I'm making sure, I'm making sure that everyone understands what is happening, okay?
Thank you.
So wait, before you leave, understand that the rooms are gonna be an open group room where you have your camera on, the teacher help room where you,
I'm not.
Show me your notes.
all right, here we go.
Sorry, 1 second.
All right, here. Okay, I got thrown off. You're gonna have a teacher help room, an open group room, and a peer quiet room for the remainder of class. And so you will choose what group you want to be in for the remainder of time we have. All right, you can go.